Solving rational equations. This is generally easier to do if we eliminate the fractions before we solve. And we do that by multiplying both sides of the equations by the LCD, by the least common denominator. Okay, so our first equation is 9/28 plus 3 over z plus 2 equals 3/4. Our first step is to find the LCD, find the least common denominator. And we need to, an easier way to do that is by finding the prime factorization of the denominators. So 28 is equal to 2 squared times 7. Z plus 2 is factored as much as it could be, and 4 is equal to 2 squared. Now we need to take each factor that we see, like the 2, the 7, the z plus 2, and raise it to the highest exponent that we see. So we need the 2 squared, and in both cases that we see the 2 it's squared. We need the 7, and we need the z plus 2. Our LCD will be formed by taking 2 squared times 7 times z plus 2, which is equal to 28 times z plus 2. And we could multiply that out, but we don't need to. Our next step is to multiply each side of the equation by our LCD by 28 times z plus 2. So 28 times z plus 2 times 9/28 plus 3 over z plus 2 equals 28 times z plus 2 times 3/4. I can distribute and get 28 times z plus 2 times 9/28 plus 28 times z plus 2 times 3 over z plus 2 equals 28 times z plus 2 times 3/4. Now we're going to cancel common factors. Now remember, this LCD is in the numerator, so we can put it over 1 in all three of these places. So now, in this first expression, I can cancel the 28s. And in the second expression, I can cancel the z plus 2s. And on the right-hand side, I can cancel 4s. 28 divided by 4 leaves us with 7. Okay, now we're going to simplify. So when I multiply, I get 9 times z plus 2 plus 28 times 3 equals 7 times z plus 2 times 3. Let's distribute and simplify more. So 9 times z is 9z, 9 times 2 is 18, plus 28 times 3 is 84, equals 7 times z times 3, or 21z, and 7 times 2 times 3 is 42. Let's combine some like terms. I get 9z plus 102 equals 21z plus 42. Let's solve for z. So if I subtract 9z from both sides, I get 102 equals 12z plus 42. Let's subtract 42 from both sides. 60 equals 12z. Divide by 12, z equals 5. The last step is to check our solution. It's important to check solutions with rational equations because we could get extraneous solutions. So we're substituting 5 in for z, so we're checking, does 9/28 plus 3 over 5 plus 2 equal 3/4? Or does 9/28 plus 3/7 equal 3/4? For these three fractions, our LCD is 28. So we're going to convert all these fractions so they're over 28. 9/28 stays the same. 7 times 4 is 28, so 3 times 4 is 12. 4 times 7 is 28. 3 times 7 is 21. So I've got 9/28 plus 12/28. We're checking, does that equal 21/28? It does indeed. So z equals 5 checks out as a solution. Let's look at a second example. X plus x squared minus 5 over x squared minus 1 equals x squared plus x plus 2 over x plus 1. Here we need to start by factoring the denominators. So x we can put over 1 for now, plus x squared minus 5, and the denominator factors, because we have a perfect square, minus in between. We put 2 parentheses, the square root of x squared, the square root of 1, and 1 gets a plus and 1 gets a minus, equals x squared plus x plus 2 over x plus 1, because that can't be factored anymore. Let's find our least common denominator. Okay, so we see a 1, an x plus 1, and an x minus 1, and another x plus 1. We need to take each factor, and so our LCD will be formed by doing the product of x plus 1 times x minus 1. Let's multiply each side of the equation by the LCD, and we can go ahead and distribute as well. X plus 1 times x minus 1 times x, plus x plus 1 times x minus 1 times x squared minus 5 over x plus 1 times x minus 1, equals x plus 1 times x minus 1 over, or times x squared plus x plus 2 over x plus 1. We'll cancel common factors. Remember, these LCDs can be put over 1. And so in our second product, we can cancel x plus 1s and x minus 1s. On the right-hand side, we can cancel x plus 1s. Simplifying, right now we're left with x plus 1 times x minus 1 times x, plus x squared minus 5 equals x minus 1 times x squared plus x plus 2. Let's multiply. X plus 1 times x minus 1 is x squared minus 1, and it still needs to be multiplied by x, plus x squared minus 5. X times x squared is x cubed, x times x is x squared, x times 2 is plus 2x, negative 1 times x squared is negative 1x squared, negative 1 times x is minus x, negative 1 times 2 is minus 2. On the left-hand side, x times x squared is x cubed, x times 1 is minus x. We still have plus x squared minus 5 equals x cubed. Combining my x squares, they're going to cancel out. Combining my x's, 2x minus x is plus 1x, and still have minus 2. Okay, let's solve for x. Let's subtract x cubed, and they cancel out. Let's subtract x's, and I have x squared minus 2x minus 5 equals negative 2. It's quadratic, so let's get everything on one side, 0 on the other. So let's add 2 to both sides. X squared minus 2x minus 3 equals 0. Let's factor this. Put in our x's. Two numbers that multiply to negative 3 but add up to negative 2 are negative 3 and positive 1. Okay, that product equals 0, so let's zero product. Let's set each factor equal to 0. X minus 3 equals 0, or x plus 1 equals 0. Solve for x. Add 3's. X equals 3. Subtract 1's. X equals negative 1. So we potentially have two solutions, 3 and negative 1. But don't forget, we need to check. So let's first check x equals 3. And we're going back to our very original equation. So substituting in 3 for x, 3 plus 3 squared minus 5 over 3 squared minus 1. Does that equal 3 squared plus 3 plus 2 over 3 plus 1? We get 3 plus 4 eighths. Does that equal 14 fourths? 3 plus 1 half. Does that equal 7 halves? The LCD is 2. So does 6 over 2 plus 1 over 2 equal 7 over 2? Yes, it does. So 3 checks out. Let's check x is -1. So -1 plus -1 squared minus 5 over -1 squared minus 1. Does that equal -1 squared plus -1 plus 2 over -1 plus 1? -1 plus -4 over 0. Does that equal 2 over 0? Well, this is an issue or a concern. We can't divide by 0. This is undefined. So -1 is not a solution. It's extraneous. And our only solution was x equals 3.